Hello students, today's agenda is to check your homework. We'll be working with two-way frequency tables and you will be able to do 12.4. So today students will be able to create two-way frequency tables to then find different types of probabilities including joint, marginal, and conditional. And so let me start by giving you some definitions. And so we have been looking at numerical data in previous lessons, and this is data that is related to numbers. Data that is related to numbers. And when we talk about data related to numbers, we're talking about weight, for example, because you're asking people for specific numbers, their height, shoe size, velocity, grades, and that could be more like percentages of what students get on their grades, age, and there are many more, but these are among some numerical data. And there is also categorical data. And categorical data refers to when people are grouped by certain categories, and you'll understand more when I give you the examples. When we group people into categories. And it could be eye color, favorite color, types of food, maybe choosing among 3 foods, like we have people vote to bring for a potluck or something, race, gender, favorite subject matters, favorite subject, places, music, type of music that they like, and we might choose. So this just among many others. Okay, so again, numerical data is specific, like obtaining specific numbers, and categorical data is like grouping people. There are this number of people in this category. There are this number of people in this category, and we'll come up with some samples right now. So we're going to be working mainly with categorical data. In previous lessons, we worked with this before for the mean, median, and mode, and to create certain types of graphs. But we're going to be working with categorical data now. So I asked a class of 16 students what their favorite, not their favorite, but actually if they were to choose out of 3 ice cream flavors, which one would they choose? And so with that information, I created what is a two-way frequency table. And so let me see if I have enough space here. You can draw this table as I go so that you can follow me. Maybe I'll need one more column in here. Okay, and so the 3 questions that I asked was if they would prefer strawberry, vanilla, or chocolate. And out of those, I separated them among males and females. So my total number of students, which I'm going to put here, the grand total of students was 16. Okay? In that one class, so let me put here total. I had a total of 3 males. Notice how I'm dividing total of 3 males. And then I had 13 females. Okay, if you notice, when I add this, that add up to the 16 students that I had. At the same time, well, I need to show you. When I asked, out of my 3 males, 2 like strawberry, none of the 3 liked vanilla, and 1 of them liked chocolate. Okay? Of my females, 6 liked strawberry, 3 like vanilla, and 4 of them like chocolate. So now I can see the total of students that like strawberry. So if I add the 6 plus the 2, that's a total of 8 students, including both females and males, that like strawberry, 3 that like vanilla, and 5 that like chocolate. Again, those that like strawberry plus those that like vanilla, that's 11, plus those that like chocolate is the total of 16. So that's why it's called two-way frequency tables, because you're looking at this way, you get the total of 16 students, and then you also have data of the categories, 2 different categories. Their favorite out of these 3 flavors, and the other category separating them into male or female. Okay. Okay. Before we go into our probabilities, we're also going to create another type of two-way frequency table, but this is the relative frequency table. And so I'm going to create another similar to the first one. So you can go ahead and start working on that and filling in the same headings, and this same column, you can fill it exactly the same, except not the numbers, because that's going to be something different. So male, female, total, strawberry, vanilla, chocolate, and total in here. And so what we're going to be doing is that we're going to be using this same data, and we're going to use our calculator to figure out what goes in each one of these numbers. We always have to have a 1 in here, because 1 is like the total, the 100% of my group. Okay, and so what we're going to be doing is that to fill this part in, we're going to put this same number divided by the grand total. Okay, so 2 divided by 16, basically 2 divided by 16, and it's going to be 0.125. And here it's going to be 0, right? Because 0 divided by any number is 0. 1 divided by 16 is equals to 0.0625. And then, same here, 3 divided by 16 is equals to 0.1875. Then we go to the next one. and it's going to be 6 divided by 16 is 0.375. 3 divided by 16 is, so 3 divided by 16 is 0.1875, and I noticed that it's the same number, so you should get the same. In here it's going to be the same number, so you can just write it down if you want to. 4 divided by 16, it's actually 1/4, so it's 0.25. 13 divided by 16 is equal to 0.8125. 8 divided by 16, if this number is half of that, it's always going to be 0.5, or half of it, so 0.5. And 5 divided by 16 is equals to 0.3125. So this is just another way of representing the data shown in these two-way frequency tables. Relativity just means that these, when we add these together, should give me a total of 1. When we add these together, it should give me a total of 1. But at the same time, all of these are going to give me the total of 1. If you add all of these as well, 6 plus 3 is 9, plus 4 is 13, 14, 15, 16. So this is a total of 100%. This is a total of 100%, and this is a total of 100%. Okay. So two-way frequency tables, two-way relative frequency tables. Okay. So we're going to be working mainly with this information, and I think I'm just going to fold it so that you can have it present. If you need to copy the examples or fill this in, you can pause the video. Let me fold it a little bit more. This is just scratch paper, so just ignore those extra examples in there. Wow, okay. There you go. Okay, can you see all of them? Okay, so I'm gonna start showing you the different types of probability and how to find it. And we're going to start with, let me see, maybe I can just focus it a little bit more so that we can see it all. So we're going to start with joint probability. And joint probability refers to basically the numbers in the middle. Okay? And why is it joint? Because these two students are both male and they like strawberry. This one student is both male and like chocolate. These 6 students are female and like strawberry. So basically, they have two types. They belong to both of the categories that we're pointing out. Okay, so that's why it's called joint probability. So I'm going to show you some examples. For example, we can say, what is the probability of somebody being male and liking strawberry? Okay, so we go to male and strawberry, that's going to be 2 out of 16 students. Okay, 2 out of 16 students like strawberry and are male. They belong to both of these categories. Another way to annotate or to write the symbol that we use for this joint probability is like this. So we can say probability of somebody being male, and instead of writing the word and, we just write this symbol, liking strawberry ice cream. So again, we said that it's 2 out of 16. If we simplify that, that would be 1 out of 8. If we divide 1 by 8, it's 0.125. That we can just use this table right here. If you notice, it's 0.125, or we can just divide in here instead of creating another table. And we're gonna also write it, I'm gonna ask you that you please write it in fraction, decimal, and percent. So you're gonna move these 2 spaces, so it's gonna be 12.5%. Okay, so you just wrote now your probability of somebody being male and liking strawberry ice cream as 2/16. Simplify it, divide it to make a decimal, and then move the decimal 2 spaces to make it a percent. Okay, so something that we need to know is that joint probability refers to these numbers in the middle. Okay, so I'm just gonna color it so that you can see the reference. Now, what is the probability of somebody being male and liking vanilla? Okay, the probability okay, so we go to the male and vanilla, which is equals to 0 out of the 16. In decimal form will be 0.0 or 0.0 or just 0, and that's 0%. Okay. And maybe what about what's the probability of somebody being female and liking chocolate maybe? So the probability of being female and liking chocolate will be 4 out of 16, which if we simplify is we divide both by 4, so it's 1/4. If you want to look at your relative frequency table, it will be 0.25 right there. So 0.25, or you can just divide it in the calculator, which is equals to, we move it 1, 2, always 2 spaces, 25%. Okay, so that's joint probability, and it refers to these numbers out of the grand total. Okay, this will be your numerator, and this will be the denominator. Okay, and this is the symbol for joint probability. Now let's go to what is called marginal probability. And you might guess what it is, but the marginal are the ones that are on the margins. Okay, so basically I'm just gonna color this pink so that you can remember that this refers to these that are on the margin, marginal, hence the word marginal or margin. Okay, so it would be only one word basically. And let's say, what is the probability that somebody likes strawberry? Okay, it's just one word because it just refers to this, so this will include everyone who likes strawberry. So it would be 8 out of the 16 once again. 8 out of 16, which is, if we divide both by 8, it's going to be 1 out of 2. Remember that 1/2 is always equals to 0.5. And if we move that 2 decimal spaces, that's going to be 50%. Okay? So, again, for marginal probability, you're going to look at the category, you're going to get the one on the outside and out of the total. So your numerator will be the number on the margin, and the number in the denominator will be the total number of students. What is the probability that somebody is a female? Probability that somebody is a female. Okay, how many females do we have in total? Again, we don't look at these individuals because they are females and they like strawberry. And that doesn't include everyone who is a female, but this includes the total of females. Okay, so it will be 13 out of the total number of 16, which is equals to, if we look at our relative frequency table, it will be 0.8125. And in percent, we move it twice. Again, if you don't want to look at this table, you can just divide 13 by 16 on your calculator. 13 divided by 16, and you get the same number. Okay? Move it twice, 2 spaces to the right to make it into a percent. So it's 81.25%. Okay? What is the probability of somebody liking chocolate? Doesn't matter if they're female or male, just anyone who likes chocolate. That's a total of 5 out of 16. Okay, you divide, you get your decimal, and then you move it twice, 2 spaces to get your percent. Okay, I'm not gonna do that one, but that's you get the point. Okay, there is one that is called, maybe I should use a different, I'll use a different page. The next one is called conditional probability. And conditional probability refers that we already know part of the information, okay? We already know part of the information. And there is a special right to write it, but it also, for example, I'm just gonna show you right now. The probability of somebody liking vanilla, knowing that, this is kind of like knowing that the person is female. I'll write the whole sentence of how you will read this. This is read as, okay, so we already know that the person is a female, but we don't know if they like the vanilla or not. We're gonna find out what's the probability of that happening, okay? But we already know that they're female. So let me write in quotation marks how you would read this. So what's the probability? What is the probability that somebody likes vanilla? So what is the probability that somebody likes vanilla and then this is read as knowing that the person is female. the person is female. That's why I love math, because with this, we're saying all of these words. What is the probability that somebody likes vanilla knowing that the person is female? Okay, so let's figure that out. And something that you need to know, or that I find a lot easier to understand this part, is that all you have to do is look at the second word, female, in conditional probability. Look at the second word, and I just go to the total of that word. So females, the total is 13, and that's going to be my denominator. Okay, this is my denominator. So to begin with, this tells me that this is conditional probability, in that the second word tells me what's going to be in my denominator. Okay, and out of those, I'm just going to go on that column of my females, right? On my row of females, and I look for those that like vanilla. Okay, not the total, well, in this case it will be the same, not the total of those that like vanilla, but just the number of females that like vanilla. So it would be 3. Okay, and 3 divided by 13, right? It's by 13. We don't, this is conditional probability, is the only one that we don't get the total, but rather the marginal number. Okay, so 3 divided by 13. Let's just round to the nearest hundredth. So it's going to be 0.23, or maybe even 1,000, but in this case it's a 0, so it's okay. And for the percent, we're going to move it 2 spaces, so it's going to be 23%. Okay. Okay, one more example. What is the probability? So let me change it. Let me change it a little bit. What is the probability? Whoops. That somebody's male knowing that the person likes strawberry? Okay. Again, this tells me that I'm going to look for the denominator as the total of strawberry. So, can you see it? The total of strawberry is 8, so that's going to be my denominator. And out of those 8 that, you know, we have girls and boys that like strawberry, but out of those, how many are male? So it would be 2. If we simplify that, we divide both by 2, and so it's going to be 1 over 4, sorry about that. And 1/4 is the same as 0.025. We move it twice, and so it's 25%. So 25% of males, knowing that they're like strawberry, the probability that I'm gonna get a male knowing that they like strawberry is 25%. Okay, I was kind of switching that. Okay, again, when you have conditional probability, this tells me the number in the denominator, and it's only on the margin. Okay, and once I find that number, I just go to look at the second category. In this case, for the males, out of the strawberry, males is 2, and so that's my numerator. I think I want to do one more example just to make sure, because I think out of the 3 types of probability, this is the one that is a little bit more confusing. So let me see. make up one right now. What is the probability that somebody likes chocolate knowing that the person is female? I guess I should have put male, but that's okay. So again, this tells me that it's conditional probability and that this is my denominator. So in my denominator, I'm going to look for females. So total females is 13. And of those 13 female, four like chocolate. We cannot simplify that. We divide 4 by 13. Again, you can just go and look at the, oh no, you cannot look at the relative frequency table because the other one is out of 16. So in here it would be 0. Let's round it to 0.307. So this will become 8. 0.308. We move it 2 spaces. And so it's going to be about 30.8%. Or if you round it more, it's 31%, okay? I would accept both. Okay, so let's summarize really fast. So we have all 3 in here. Joint probability is when you have this symbol and it's the numbers in the middle out of the total. Okay, this is my numerator, this is my denominator. Marginal probability, it has only one word. So if it's a strawberry, you just go to the grand total strawberry out of the total number of students. Again, this is my denominator. And for conditional probability, you will get, first work with the one that you already know we have, and then go from there. Like if we're talking about female, the grand total is, not the grand total of students, but the total of that category. And then you look for the probability within that row, if it's a row. Or you look for strawberry, the total of strawberry, and then you look in that column for the numerator, okay? So basically for conditional, you're just gonna be working with these numbers and this. These will be your numerators. These will be your denominators. And this one is not involved in conditional probability. And I think that's it. Hopefully it's not as confusing as it seems. If you have questions, you can always ask me. And now you can work on 12.4.